Hi everyone, welcome to lesson 3. So the topic for this lesson will be order for real numbers as well as absolute value. When we talk about order, what we mean is putting numbers in order and getting familiar with these inequality symbols of less than as well as greater than. We'll also see less than or equal to and greater than or equal to. Okay, so just a reminder, the less than symbol kind of looks like this L shape. It sort of points to the left. This refers to numbers that are to the left on the number line. So for example, 2 is less than 3 because 2 is to the left of 3 on the number line. Then the greater than symbol, sort of the opposite, it's sort of pointing to the right. If you say a number is greater than another one, what you mean is it's to the right on the number line. So for example, 5 is greater than 4. That means 5 is further to the right on the number line than 4. Okay, and then that brings us to absolute value. Okay, so when we talk about the absolute value of a number, technically the definition is the distance from 0 on a number line. So in other words, how far away is that number from 0 on the number line? Something to keep in mind, distance is never negative, only positive, or it can be 0. So for example, if I want to know the distance from my house to the house next door, it doesn't matter whether that house is to the right or left or east or west. The distance is just positive. Might be 30 feet or 1 mile or whatever, but I would never say that the distance is negative 1 mile. So distance is never negative. Absolute value is also never negative. Here's some examples. When you see these sort of two vertical lines surrounding a number, that means absolute value. So for example, the absolute value of 4, that refers to how far away is 4 from 0 on the number line. So here's 4 on the number line. Notice that it's 4 units away. The distance is 4. So the absolute value of 4 is 4. Okay, seems simple. Well, what about a negative? If you are asking about the absolute value of a negative number, like the absolute value of -4, how far away is that number from 0 on the number line? The distance is still 4. Okay, so absolute value, you might just remember it's just never negative. It's just always positive. So be careful. Sometimes people mix this up and say, you know, if the absolute value of -4 is 4, they might say, oh, we always change the sign. That's not the case. If you have a positive, you keep it positive. If you have a negative, the answer is positive. So absolute value, always positive. The exception would be if you have the absolute value of 0. How far away is 0 from itself? 0. Okay, but you'll never have a negative as an answer here. All right, so let's look at some examples on the next slide here. What we're going to be seeing here are some examples with absolute value as well as using less than or greater than symbols. Then we'll go through some true false examples as well. The notes for this lesson are fairly short, so after we go through these examples, I'm also going to switch over and we'll do some slightly harder ones on the homework, but it's still kind of the same concepts. Okay, so the first 3 problems over here, it says fill in each sentence below with the less than symbol or the greater than symbol. And then I have a little note that says change fractions to decimals. Okay, so we'll get to that. That comes up in our third problem. Let's start with number 1, 3.7. Then there's a blank, and then 3.08. What we want to know is which symbol should we put in between? Is 3.7 less than 3.08? Or is 3.7 greater than 3.08? Okay, so sometimes with decimals, it helps to think about them in terms of dollars and cents, possibly. So if you think about 3.7, what would that be as a money amount? It would be $3, and this would actually be 70 cents. So if that money comparison helps you, great. If not, just notice what I did here, which is I added a 0 after the 7. This is something important about decimals. If you want to compare decimals, make sure they both end in the same decimal place. So notice how the 3.08 goes out to the hundredths place, 2 places beyond the decimal point. We really need that to be the case as well for the other number in order to compare them correctly. Because otherwise you might get mixed up and think, oh, 7 is less than 8, so I put a less than symbol here. But actually, if you think about this as 3.70 compared with 3.08, the 70 hundredths is actually greater than 8 hundredths. Or going back to the money example, $3.70 is actually greater than $3.08. Okay, so however you work it out, probably adding a 0 will help with this. You're comparing these two numbers. 3.70 is equal to 3 and 70 hundredths. The 70 hundredths is greater than the 8 hundredths in the other decimal. So in other words, greater than is what we're going to put there. Okay, we'll come back to that concept of comparing decimals because that will become relevant even with some fraction problems, which we'll see in a few minutes. All right, let's look at number 2. This is an absolute value question. The absolute value of -9 compared with the absolute value of -5. Well, let's simplify the absolute values first. So the absolute value of -9, that's just 9, right? Because the distance from -9 to 0 is just 9. The absolute value of -5 is 5. So that suddenly makes this problem easier, hopefully. 9 compared to 5, we would say 9 is greater than 5. Okay, that's all I have to say about that one. All right, good. Number 3, we're comparing the absolute value of -3/5 with 2/3. So first of all, the absolute value of -3/5 is just 3/5. And now we need to compare this with 2/3. Now there's a few ways to do this. You can compare fractions by giving them common denominators. The thing is, I've seen on the homework, some of the denominators are quite large. For example, you might have a denominator of 29 and another denominator of 37. It's going to be annoying to try to get denominators, common denominators with numbers like that. So what I'm going to show you here is actually changing these fractions to decimals in order to compare them. I'm going to take this to a separate screen temporarily. Okay, so we're going to compare 3/5 with 2/3. Okay, so 3/5, oops, compared with 2/3. Let's change each of these fractions into decimals, and let's do that by dividing. So I'm going to divide 3 by 5, and then we'll divide 2 by 3. Okay, so let's do 3/5. Notice how I put the numerator inside the long division symbol, and I'm dividing by the denominator of 5. So 5 doesn't go into 3, so I immediately put a 0, put a decimal point, and line up the decimal point. 3/5 is less than 1, so I know this is going to be 0 point something. Let's add a 0 after the 3, and now how many times does 5 go into 30? We can say 6. And there's a remainder of 0, and we're done. Okay, so we're starting with the decimal of 0.6. Now let's move to our second decimal, or a second fraction over here, 2/3. 2 divided by 3. Okay, so 3 doesn't go into 2, so I'm putting a 0, just like the last problem, lining up a decimal point, adding another 0 after the 2. How many times does 3 go into 20? Okay, that's actually also 6 times. 3 times 6 is 18. I'm subtracting, getting a remainder of 2. Now I don't really want a remainder with decimals, so let's add another 0 and bring it down and see what happens next. How many times does 3 go into 20? Okay, that sounds familiar. It's 6 times. 6 times 3 is 18. Getting a 2, bring down the 0, 20. How many times does 3 go into 20? 6 times. 18, 2. See how this would go on forever? This is a repeating decimal. So this is never going to end. Sometimes you can answer this with a little bar over the 6 to show that the 6 repeats forever. But back to the original question, how are we going to compare this to the other decimal? Well, the way I think about it is for the first decimal, if there's something repeating after the 6, it's just a bunch of zeros. So let's just write a couple zeros here, 0.600. If I compare that with 0.666, 666, that is greater than 600. So actually, the way to say it the other way is 0.600 is less than 0.666. So 3/5 is actually less than 2/3. Okay, so what we just showed here is changing fractions to decimals in order to compare them. Now, I mentioned getting common denominators. These fractions, we could fairly easily get common denominators. So here's another way to do this problem. I'm going to change it to a different screen again. If you feel comfortable getting common denominators to compare your fractions, that's a completely valid way to do this as well. So let's get a common denominator of 15, because 3 times 5 is 15. So that would become 9/15 for the first fraction. 5 times 3 is 15, 3 times 3 is 9. And then for the second fraction, 2/3, 3 times 5 is 15, 2 times 5 is 10. So see how now we can compare 9/15 with 10/15. Now we can more easily compare them because they have common denominators. 9 is less than 10, so 9/15 is less than 10/15. So we can still end up with the same answer of using that less than symbol. But notice we really couldn't do anything until we did some kind of change to the fractions. 3/5, 2/3, we can't really compare those until we either change them to have a common denominator or change them to have, or change them into decimals. Okay, because as you may have noticed, the numbers in the first fraction, 3 and 5, appear to be bigger than the numbers in the second fraction, 2 and 3. But that kind of has nothing to do with your final answer of which one is larger. You really need to convert them. Okay, so let's go back to our notes. Okay, so we just went through our first 3 examples, filling in the blank with less than or greater than symbols. And I believe we just came up with 3/5 being less than 2/3. Okay, let's move over to the next 3 examples. These are true-false questions, and they all have different inequalities. All right, notice some of them have this little line underneath that implies equals. We'll get to that. Let's start with number 1. True or false? -8 is less than -11. Okay, with negatives, things are extra tricky. I would recommend kind of sketching this out on a number line and putting these in order. Okay, so here's 0. If I'm dealing with negatives, everything's kind of backwards, right? So here's how I would label my number line. 0, -1, -2, -3, etc. -4, 5, 6, 7, here's -8, and then 9, 10, here's -11. Okay, so notice how when we set up our number line, -11 is actually further to the left than -8. So -11 is actually less than -8, which means -8 should actually be greater than -11. So that original statement, that was false. -8 isn't less than -11, it's the other way around. Okay, so notice how we sketch that out on a number line. Sometimes just saying it out loud can help you make sense of whether the statement is true or false. And just be careful because negatives can easily confuse us. Okay, so again, number 1 in this little set, -8 less than -11 is false because -8 is actually greater than -11. Okay, let's move on to number 2, 7/12 greater than or equal to 5/6. Okay, this is another comparing fractions question. Clearly, they're not equal to each other, or maybe not so clearly. We can figure that out. This symbol right here, greater than or equal to. It would be true if 7/12 is greater than 5/6. It would also be true if 7/12 is equal to 5/6. It can't be both, but if one of those things is true, we would say true. So we can now decide, do we want to change these into decimals to compare them? Or do we want to change them to have common denominators? I think for this one, common denominators is probably the easier way to go. 6 times 2 is 12. So I can just multiply by 2/2. So that 5/6 becomes 10/12. Then I can more easily compare them, 7/12 to 10/12. Yeah, so 7/12, that's not greater than 10/12 or equal to 10/12. 7/12 is actually less than 10/12 because 7 is less than 10. So I would say false for this one as well. Okay, another way to compare them, of course, would be to change each one into decimals. We'll see some more examples of those on the homework in a few minutes when we have some harder denominators. So I'm going to leave that one for now. We were able to compare the fractions by getting common denominators, and we decided this answer was false. Okay, number 3, 7.5 is less than or equal to 7.5. So 7.5 is actually equal to 7.5. Those are literally the same number. So because this symbol does have a line underneath it, we would say this is true because yes, 7.5 is equal to 7.5. It's less than or equal to. Obviously it's not less than, but it is equal to. Okay, so we would say true, okay, because of the equals. Now, if it was 7.5 is less than 7.5, we would have to say false for that one. So the only thing that makes this problem true is that line underneath the inequality, because that's implying that the numbers are equal. Okay, so that's as far as we're going to go with notes for this lesson. What I'm going to do right now is pause, and then when I restart the video, my screen will be switched over to homework number 3. We're going to take a look at a few more examples there just to make sure we've covered our bases with the topics in this section. All right, so here we are looking at homework number 3. There's 22 questions. They start off with a lot of less than and greater than questions here. I wanted to skip ahead to maybe some slightly harder problems with fractions. Here's number 2. I think we can do this one fairly quickly. Insert either less than or greater than for the blank to write a true sentence. So this one is -1/8 and -1/4. 4 goes into 8, so I think this is an example where we can change the fractions to have common denominators. So I can do a common denominator of 8 here. The 1/4 can just change to 2/8. If I multiply by 2, -2/8. So I can compare -1/8 with -2/8. Okay, now be careful. These are negatives, obviously. Let's see, -1 and -2. Those are really the numbers we're comparing. I'm just going to remind myself of my number line. So -1 is actually greater than -2 on the number line because it's further to the right. So -1/8 is going to be greater than -2/8. Okay, so in this case, rather than typing it in, I get to choose a little drop-down menu and pick my symbol here. So I'm going to pick the greater than symbol for that one. Okay, so as always, be careful with your fractions, be careful with your negatives. All right, let's see, number 4. This is -4.4 and then -9 7/9. Now what I was originally going to have us do is change that fraction into a decimal. But here's the thing, we don't really need to because -4 and -9, those are really the things we're comparing. The decimal or fraction that comes after it's not going to change the ultimate answer, the ultimate final answer. Okay, so just think about -4 compared to -9. -4 is further to the right on the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9. So see how -9 is further away from 0 to the left. -4 is further to the right. So -4 is greater than -9. That's all we need to do for this one. It's not necessary to change fractions or decimals or anything. We can really just focus on the whole numbers. So hopefully that's a little reassuring. Some of these maybe aren't quite as hard as they might look. All right, let's see. Oh, here's one that we should change. -2/5 compared to -0.61. Okay, when you're comparing a fraction with a decimal, and it's not a mixed number like the previous problem we did, we should change the fraction into a decimal. So let's change -2/5 to a decimal. Let's divide 2 by 5, add a decimal after it. 5 doesn't go into 2, so there's your 0. 5 does go into 20 4 times. So it looks like we're comparing -0.4 with -0.61. Okay, I'll put a 0 after the 4. So think about -0.40 with -0.61. I know 61 is greater than 40, but -61 would actually not be greater than -40. So it's sort of switched, right? So -40 would be greater than -61 because -40 is sort of closer to 0. It's further to the right on the number line. Now I know I just I just talked about these as if they were integers and not decimals, but it's really the same idea. Negative 0.40 is going to be greater than negative 0.61 because it's a little further to the right on the number line and closer to, yeah, further to the right on the number line. I'll leave it at that. Okay. Here we go. This is a harder one I was thinking of. This is number 7. We're comparing two fractions, 2/17 compared with 6/29. Okay, so the common denominator would have to be 17 times 29, whatever that is. It's a little bit bigger than I want to go. So, because remember, we're not using calculators yet. So what I'm going to have us do is let's change these to decimals, but let's just keep in mind, we don't need to write out the full decimal for each one. If we just divide maybe out to the hundredths place, that'll probably be enough to compare the two. Okay, so let's do 2/17, and then we'll do 6/29. And again, let's keep in mind, we don't need to take up our whole paper with super long division problems. Let's go out to the hundredths place. So 2 places past the decimal point. That should be enough. Okay, so let's start with 2/17. Add your decimal, add your 0. 17 doesn't go into 2, so we put a 0. 17 goes into 20 one time. So I'm writing a 1, then subtracting. 1 times 17 is 17. I get 3. I'm going to add a 0 and bring it down. 17 times 2 is 34. So actually, still, 17 only goes into 30 one time. Subtract. Get 13. I'm going to stop there. So I'm getting 0.11 so far. Obviously, I could keep going, but I'm going to stop there. Let's move on to the other fraction here, 6/29. Adding a decimal, adding a 0. 29 doesn't go into 60. 29 times, let's see, I think. Oh, sorry, I said it wrong. My apologies. 29 doesn't go into 6. 29 does go into 60. The question is how many times? 9 times 2, let's see, 18. 2 times 2 is 4, plus 1 is 5. Okay, so 29 times 2 is 58. That's just under 60. So I can write a 2 here. So that's actually enough to compare these. Because see how there's a 2 in the tens place, and before there was only a 1 in the tens place? That's going to answer our question. But let's just keep going, just to be a little more thorough, out to the hundredths place. 2 times 29 is 58. Getting a remainder of 2, bring down the 0. How many times does 29 go into 20? 0 times. I would be able to bring down another 0, but I'm going to stop here. So let's just compare these decimals. They're not complete answers, but this is enough to make our comparison. So 0.11 compared to 0.20. In other words, 11 hundredths compared with 20 hundredths. 11 is less than 20, so that answers our question. So we're going to type in a less than symbol here. Okay, and as you can see, you can choose it from your toolbar down here, or you can use your keyboard to type it. All right. So on a test, if you're doing a problem like this, rather than just randomly guessing, this is the work I would expect to be shown, that you're dividing, you're using long division to change your fractions to decimals to make your comparison. Okay, good. So there's quite a few, oops, there's quite a few questions like this. I'm going to skip ahead a bit here. All right, when we get to number 11, the directions are a little different. I did not go over this in the official notes. Here's what it says. Write an inequality with the same meaning. So the inequality says 16 is greater than y. How do we write an inequality with the same meaning? Here's what you do. You just switch it. Okay, so for example, if I say 5 is greater than 2, I can also say 2 is less than 5. Those are saying the same thing. If I'm older than you, then you're younger than me. Okay, those are the same thing. So what I'm going to say is, instead of 16 is greater than y, I'm going to say y is less than 16. Those are saying the same thing. You just switch it. All right, here's another one. Negative 29 is less than or equal to y. We're going to switch it around, and we're going to write y is greater than or equal to, so I'll choose that button down here, negative 29. You're just reversing the order of your numbers and reversing the direction of your inequality. Okay, then we get to some true false questions. We talked about those. in the notes. They're all yes or no, or true or false. Okay, here's another fraction and decimal question. Here's another one. This is number 16, negative 22 27ths and negative 25 28ths. Let's do one more of these because they can be a little tricky. Let's change our fractions to decimals one more time. 22 27ths and then 25 28ths. All right, setting up my long division. Adding a 0, adding a decimal point. Oh boy, how many times does 27 go into 220? I don't know. Let's see, I'm gonna guess 7. 9. Let's see, not enough. Let's try 8. 56, 16 plus 5 is 21. There it is. Okay, 27 times 8 is 216. So it looks like it goes in 8 times. Okay, I'm actually going to stop here and just go ahead and try my other fraction. Maybe just dividing to the tens place will be enough. Let's find out. I might go back and forth. Okay, so I'm just going to skip on over to the 25 28ths. Added a 0, added a decimal point. How many times does 28 go into 250? Okay, so I'm going to try 8 and just see if they're the same. 64. Let's see, carry the 6. Okay, 8 times 2 is 16 plus 6 is 22. Okay, 224. All right, so 28 times 8 is 224. Let's try 28 times 9. 72, 18. Yeah, okay, shoot, it is 8. All right, well, I have to go back. So see how I've divided each of them out to the tens place. I'm getting 0.8. They're both the same so far, so we do need to keep going. All right, so let's see. 28 times 9 was too big. So 28 times 8 was 224. Okay, I'm getting 26 as my remainder. Let's make a little space here. All right, so that might be a little confusing going back and forth. I guess out to the hundreds place is a good idea after all. All right, so let's continue back on that first problem. I was doing 22 divided by 7. I added a 0, 220 divided by 27. It goes in 8 times. 8 times 27 is 216. I have a remainder of 4. Let's continue. Let's bring down a 0. Okay. And how many times does 27 go into 40? Thankfully, that's only one time. Okay, so I added a 1 here. And so now I'm out to 0.81. Now let's go back to the other problem. I had 26. Let's bring down a 0. 260. Okay, clearly this is going to be more than 1. So how many times does 28 go into 260? Well, we already know 28 times 8 is 224. So let's try 28 times 9, which I already had. That was 252. Yeah, so that goes in 9 times. Okay, now I think I have enough to compare them. So my first fraction, I changed that to 0.81. And then the second one, I'm getting 0.89. And that's as far as I need to go. Now let's also keep in mind that we're dealing with negatives. So negative 0.81 compared with negative 0.89. Okay, let's think about this. 81 compared to 89. I know 81 is less than 89, which means negative 81 is actually greater than negative 89. Because if we were to line these up on a number line, negative 81 would be closer to 0, further to the right than negative 89. Negative 89 would be further to the left. So I think negative 0.81 is greater than negative 0.89. Okay, so back to the original problem. We had this greater than or equal to symbol. Now, clearly they're not equal, but they are, this fraction is greater than the other one. So after all that, I think I'm going to say true for that one. All right, so lots of work for a true-false question, I know. But I hope I'm making it clear. I don't want you to just randomly guess. You want to be sure. All right, so the remainder of the questions deal with absolute value. These are nice and short, 17 through the end. Simplify absolute value. So the absolute value of negative 18, that's just 18. So generally, you're just going to write some positive answers here. Absolute value of 0 over negative 14. You might think that's just 0 over positive 14, but watch. It's not reduced, right? So 0 over 14, that's just 0. So the absolute value is just 0. All right. Absolute value of 5.9, that would be just 5.9. Absolute value of 19 would be 19. Okay, so remember with positives, just keep them positive. Absolute value of negative 12/5 is just 12/5. And then last question, number 22, absolute value of this negative decimal is going to become positive. All right, there you go. So you've gotten a preview of homework number 3. As always, please ask if you have questions. Please use the question help. Use that Ask My Instructor feature. That'll send me an email and I will write back to you, sometimes with a video or even a picture, or whatever you might need for a hint. Okay, thank you very much for watching, and I will see everybody soon in class or for lesson 4 coming up next. Thank you.